So now, in this video, we're going to do a step-by-step build of an op amp wired as a non-inverting comparator, but our signal is going to come from a light-dependent resistor voltage divider. The light-dependent resistor is on the high side right there, so a brighter light will be a higher voltage, and if it's bright enough, we'll have a high output. If we get it dark enough, then we'll have a lower voltage, which means that there'll be a low output if we get it dark enough. Our reference voltage is going to be with a couple fixed value resistors right there. So we could also change the reference voltage, but for this demonstration we're going to set it to half of the supply voltage. So the op amp we're using is the LM358. Let's see how well I can see the part number right there. LM358P right there. Probably an improved version of the original LM358. I got it out of this kit right there. We got the pin layout, but I also drew it on the sheet right there. And once we apply power, we're going to want the positive supply to pin 8 and the negative supply to pin 4. I'm going to power this circuit with 5 volts later on. I like to use a blue LED to light up when the output is low, to indicate when the output's low. So we got to bring it from the positive supply. The long lead, the anode, needs to be more positive. Short lead, the cathode, more negative. We'll get to that in a little bit. I'm swapping the order of the resistor and the LED. You can do that at any time. Doesn't matter which one comes first when you're headed from positive, and then when the output's low to negative there to light it up. For the red, well, for the high output, I like the red LED. So we get as close to 5 volts out as we can. I'm probably not terribly close. And actually, I'm going to add another jumper. So now, I think best spot for this jumper will be right up there. And it went in nice and quick, so we can kind of rush along. Put the LED, again, I'm going to put it near the output, but we got the cathode down there, anode up there. Anode needs to be more positive to light up. And we need to grab the 225 ohm resistor. Pretty sure that's it right there. And lighting's not the best, so let's move that over. 220 ohm resistor. So now our outputs are all wired up. So now I want to wire up the inverting input because it's higher up on the physical component, and so we won't be blocking something else that we're going to wire later. So just notice on the schematic it's lower, but on the physical component it is up higher. You always got to pay close attention to that. Always make sure you're wiring the actual component, not the way that it is on the schematic. Schematic just shows you where the connections are. So this one's going to go to positive supply right there, 10,000 ohm resistor, as well as a 10,000 ohm resistor to the negative supply, which is going to the inverting input right there. So when we have 5 volts, that's going to set about 2.5 volts, and it's going to be relatively steady. And now we're going to wire up the light dependent resistor on the high side voltage divider right there. It's to pin 3 down. Pin 3 though. Third pin down right there. So got to be aware that it's down lower, and that's one reason why I wired up that one first. So I'm going to put the fixed resistor that goes to the negative supply. It's a 3,000 ohm resistor over there. If these were closer together, I would squeeze it down to that jumper that's going to ground, but instead I'm going to stick it up there. And then I'm going to take the light dependent resistor. I can go over the integrated circuit because this is just a prototype circuit right there, and plug her in, and that is all we have to do. So now, it's been a long time since I made this circuit. I'm not sure how dark we have to get, but just in case we got to get it really dark, I'm going to remove this cap from an alligator clip so I can cover the light dependent resistor if need be. Now, we have the portable bench power supply right here, and that's kind of the best way to power prototype circuits. You may have different ways of powering your permanent circuits, but for testing and stuff, generally bench power supply, including one that is portable like this one, is probably your best option right there. So okay, looks like it is dark enough right now. This also isn't facing the light, and the light's a little bit far away. It wasn't at its brightest setting either. So now it's bright enough, the output is high. We got enough light falling on the light dependent resistor. It's raising the inverting input, the non-inverting input I mean, voltage right there above 2.5 volts. So it's less than 3,000 ohms of resistance. When I dim it, now the output is low, and I can go even dimmer. I guess that's the lowest setting. Turn the lamp off. Doesn't matter. That raises the voltage here, so it raises above 3,000 ohms. So that'll raise the voltage, or the resistance raises. So it raises above 3,000 ohms. That makes this the lower voltage right there. That's what I'm trying to say. And so we drop below 2.5 volts, and the output goes low because the output wants to be more like the non-inverting input than the inverting input, but it goes to the maximum voltage that it can go, either high or low. It doesn't stop midway. You would have to use negative feedback in order to do that, but we don't have that. It just jumps from one extreme to the other. So in any case, that's really about it for this circuit. Hope you enjoyed. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.